Okay, we're getting into some exciting stuff now. Um, we're getting into the factoring, and factoring is not going away. I promise. Um, and even in chapter 6, you'll still be factoring. All right. So make sure you watch the quick video that goes over the factoring handout. And something I want to tell you about the factoring handout is that you get to use the factoring handout on every test that you need it for. So that's a pretty cool deal. So um, I don't think you need it for chapter 3. So that's one um, about one of two tests that you're not going to need it for. And I don't know, yeah, you will need it for the final. If you have to take the final, you'll need it for that one too. So, yeehaw. I'm looking for a video that I'm going to need. Hang on just a minute. Aha, that's the one. Okay. Now, I don't need it just yet, but I will need it. Factoring greatest common factor out of this. So if you look at this, 12 and 15, 3 goes into both of those. So as I look at this, I'm going to divide both of these by 3. So I'm going to put 3 in front. 12 divided by 3 leaves 4. And make sure don't drop the x. And then 15 divided by 3 leaves 5. If there are 2 terms, there better be 2 terms inside the parenthesis. There's a reason why I do this. And one of the reasons is if there had not been an x cubed here on number 2, if there had just been an x on number 2, a lot of times people will drop that whole term thinking the whole thing goes away. But the problem is there's still something there. And if I see something physically there, then I will know that I have to have a 1 left. So if I'd have had 12x plus 3 here instead of a 15, when I divide by 3 here, then that shows me that I would have had 4x plus 1 left here, because that 3 doesn't 3 divided by 3 leaves something there. But if I would have just gone from 12x plus 3 into 3 parentheses, a lot of times what I get is 4x. I don't get the plus 1 here. So if you will do this little divide sign under here, it will help you to know that this piece doesn't just go away. Okay? So now, in Mr. Goodbuddy, if you hit math, arrow to numbers, and then arrow up, you'll see GCD. And if you hit GCD and you do 13 and 26 and hit enter, you'll find out that 13 goes into 13 and 26. And then do GCD of 26 and 39, you'll also find that 13 goes into that as well. And then the GCD of x cubed, x squared, and x is x. So when you've got multiples of these x's, it's always the lowest number of them. So then you put 13x, and then remember, if you've got 3 terms here, you're going to have 3 terms here. $39 divided by 13 leaves 3. X divided by x goes choppa choppa. 13 divided by 13. Then x cubed, 1, 2, 3, divided by x, leaves an x squared. And then 26 divided by 13 leaves 2. XX divided by x leaves x. So 13x parenthesis x squared minus 2x plus 3. So that's greatest common factor. Now, 2 terms minus in the middle. Can I take the nice square roots? Perfect square of 25 is 5. Perfect square of x squared is x. Perfect square of 36 is 6. Perfect square of y is y. Yes. So, by the way, I've got a story to tell you. The first time I taught this, I called these what they are, parentheses. Well, this guy stands up and he says, "Hey, Teach." And he was 53 years old at the time. He says, and he was a New Yorker biker dude. He says, "Hey, Teach, them look like butt prints to me." So, Now that we have found our pieces, we're going to put our butt prints and we're going to fill in our butt prints. So 5x plus 6y, 5x minus 6y. How cool is that? And then 2 terms minus in the middle. Take the nice square root. That's x. And 1. Put our butt prints. Put our plus. Put our minus. X and 1. X and 1. Done. Page next. This is going pretty quick. How cool is that? And this one is the difference of cubes. This one is the sum of cubes. So we already know our formula. And a minus b a squared plus ab. Writing it is a pain in the butt, but you know what? It helps you. Plus b squared. The more you write it, the more sense it makes. A plus b is the same formula as I just wrote. I just changed 2 signs. A squared minus, my hand's cramping because of all the writing, AB plus b squared ain't this crazy crap? I mean, some crazy stuff. Now remember what I told you. A equals b equals a squared equals ab equals and b squared equals. Now, a squared, or a is the cube root of the first term. The first term is x squared, the x cubed. Well, cube root and cube go choppa choppa, and that's x. So that's the same here. Now, I'm going to change colors. B is the cube root of the second term. So on this one, it's y cubed. On this one, it's 1. So choppa y. Cube root of 1 is 1. Now, x squared is x times x. So that gives us x squared. Now, change colors. X, a times b. So x times y is xy. And here, x times 1 is x. That says plus. Change colors. B squared, y times y is y squared. On here, on this one, 1 times 1 is 1. So we just did 2 problems for the price of 1. How cool is that? Now, number 7 is type 1. Remember, that is x plus big, x plus small. All right? Well, how can I multiply and get 6, add to get 5? So, here's how you do it. You make a little T-chart. How can you multiply and get 6? 1 times 6, 2 times 5. 1 times 6 is 7. Yeah. 1 times 6 is 6. 1 plus 6 is 7. And I have just messed up. I am getting tired. 2 times 3 is 6. 2 times 3 is 6, but 2 plus 3 is 5. I have this little dyslexic thing. I put my answers in my questions. What am I trying to get to? 5. So my 2 pieces are 2 and 3. My big is 3. My small is 2. So my formula tells you exactly how to put it together. So what do? I take my 3 and put it where big is, and I take my 2 and put it where small is. Why does this work? Well, let me go back and FOIL this. X times x is x squared. x times 2 is 2x.